Hello people and welcome back to another video. In this video, we'll be starting a new test, which is called the t-test. In our previous session, we have covered the z-test and the application of z-test in statistical inferencing. Now, in the same topic of statistical inferencing, we'll be studying a new test called the t-test. Before I begin the t-test, I wanted to make one or two things clear. First, the concepts that we have discussed in statistical inference, which includes the fundamentals of confidence interval and hypothesis testing, and the five-step procedure to solve a problem on hypothesis testing. All those concepts are going to get repeated in our upcoming sessions, including in this particular session when we are discussing t-test. So I will highly urge all of you all to practice as much as you want in the hypothesis testing and the confidence interval part. And before you watch the upcoming sessions on t-test, please make sure that the concepts of z-test, normal, normal distribution, hypothesis testing, and confidence interval are really on your tips. It will help all of you all to follow these sessions as we move forward. Now we will begin our t-test. So what did we study in z-test? What were the two fundamental conditions when we can actually apply z-test to a problem? The two fundamental conditions were, number one, your population parameter, the unknown population parameter mu, if that has to be predicted and we have to use z-test, then the population standard deviation is unknown. That is point number one. And point number two, the number of samples have to be greater than 30, because only when the number of samples are greater than 30, the sampling distribution of sample means start behaving like a normal distribution. Hence, CLT can be applied. So these were the two conditions for z-test. However, when n is not greater than 30, the distribution of sample means does not guarantee to show a normal distribution. Right? So this is where t-test comes handy. When the number of samples n is not greater than or equal to 30, then what happens is that central limit theorem cannot be applied, and we cannot say with 100% assurance that the sampling distribution of sample means will be a normal distribution. Therefore, in these scenarios, we'll go down the route of t-test. But apart from this, a few other concepts, they remain sacrosanct. Now, these concepts we have already seen when we were discussing z-test. So, if you remember in z-test, we discussed the test statistic of a test. It was x bar minus mu upon s by square root of n. In this case, for calculating the test statistic for t-test, it remains the same. X bar minus mu upon s upon root of n. This value of calculating the test statistic, it remains the same for t-test. Only thing is, you need to remember, you need to apply z-test when n is greater than or equal to 30, and t-test when number of samples is less than 30. Now, since the calculation of test statistic remains the same, what changes in t-test is how do you calculate the critical t-value. Now, the critical t-value calculation we'll be seeing in our upcoming sessions, but if I have to extrapolate the results of confidence interval that we saw for our z-test, so for z-test, our confidence interval this was x bar plus and minus critical value of z into sigma by root n Now for the corresponding t-test, this will be x bar plus and minus t critical into s by root n. So this value of t critical, this value of t critical is basically the critical value at confidence level C and degree of freedom n minus 1. All right. And if you clearly see the general idea of confidence interval, it matches to that. It is estimate plus and minus margin of error. Margin of error for a t-test is t critical into s by root n, right? So what is this degree of freedom n minus 1? How do you calculate the critical value for a t-test? All of these pointers we'll be seeing very soon in our upcoming sessions. Now, a couple of properties that you need to understand for a t-test is that, as we mentioned, that t-test is applicable when the number of samples are not greater than or equal to 30. So if this is my this part is wasn't drawn properly. We redraw this once again. This is my normal distribution. If this is my standard normal distribution curve, then my t distribution will look somewhat like this. It will look somewhat like this. It won't be able to reach that maximum peak that standard normal distribution reaches. And as the number of samples increase, the normal distribution, the t distributed curve and the standard normal distribution curve will superimpose, and hence CLT will be applied, and hence it will start following a normal distribution. But if the number of samples are less than 30, this t distribution, it varies with the sample size. So let me choose another color. So as I change the number of samples, this peak and variability of the t curve, this changes as well. And we can see that the variability of a t distributed curve, which is this length, it is much more than a standard normal distribution curve. So two properties to remember for t distribution: it varies with the sample size, and number two, the variability of a t distributed curve is more than that of a standard normal distribution. Now, with these things in mind, we have discussed the fundamental concepts of t-test. Please go over these basic ideas once again, and we'll continue our discussion in the next session. Thank you so much for watching. I'll see all of you all in the next video.